Okay, so this is the calculator section. You have to be real careful with the first question. And I know some of you already did corrections on this, but this is more for those who never got it done. You have to understand that this literally means 1 over sine. So it's actually 1 over sine 4.9. You want to make sure your calculator's in radian mode as it says up above. Okay, so just type literally 1 over sine 4.9. So this comes out to negative 1.018 if you round to the nearest thousandth. So what people did wrong on this one was they tried to type it like this, sine of 1 over 4.9, which is not correct. Okay? So just remember, cosecant means 1 over sine, is what it means. Okay, that's number 1. Number 2, use a calculator to find inverse cosine of 0.6229. So if you type that, you get 0.8984. Okay? So you just type it directly, 0.8984, or to the nearest thousandth, you could just write that. Notice that there's no other answer to this question. Inverse cosine is a function. You actually made a note card for it. Remember when you graphed inverse cosine x and it looks like this? And it goes between 0 and pi here, and on the x-axis between positive 1 and negative 1. You actually made a note card for it, a flashcard. And so how could it possibly have more than one answer? See? It can't. It's a function. One output only. Okay, the next problem is a little hard to type because you might not have a button for it. But if you understand what it's saying, it's just saying what angle has a cotangent of negative 15.1. So there's so many ways to kind of rewrite the question. And so what you could think of this as is, what is this? What is this? What is this? Just set it equal to x, right? Which x equals is the mathematical way to write what is. Think about it. What is, in mathematics, would be x equals what is. Okay? So you just wrote that, and now you can just cotan both sides. So that converts to this. See? Which then can be flipped over to read tan x equals negative 1 over 15.1. And now you do have a button to solve it. Which button is it? Careful. Which button would you need to use? Inverse tan. Right. So this is kind of an awkward problem. But what you actually type is tan inverse of the reciprocal of the inside. So what I did was I first wrote what is. I wrote that mathematically, which gave me this statement. I then did a cot on both sides, which got rid of the cot. Then I reciprocated it, and now I'm in a position to solve the problem. Inverse tan both sides. Okay? All right. So inverse tan negative 1 over 15.1. And so it's negative 0.066 rounded to the nearest thousand. Okay, now I just want to say something about this particular problem. The arc-cot graph is a flashcard we never made. Okay, and there's a reason I didn't have you make an arc-cot graph flashcard. The reason is different textbooks have different arc-cot graphs. Okay, I know that's really weird. You would think that mathematicians could agree on something, but we know that cot looks like this. And when mathematicians tried to make an arc-cot graph, they had to pick a 1-to-1 portion. So this is the cot graph. Okay? And so they had to pick a 1-to-1 portion so they could invert it. So some people picked this red piece and flipped it horizontally, you know, like we do inverses. But some people said, no, 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 let's pick this piece and do that. See? So there are two arc-cot graphs, unfortunately, out there in the world. Maybe someday they'll decide which one's better. The first one looks like this. And the second one looks like this. Give me a second. Hard for me to draw. I think it's right here. Like that. So which is the right one? even the math, hold on. This is still wrong. Oh, I drew that one backwards. I meant to draw it going this way, I think. Anyway, my point is, since mathematicians can't even agree on it, I didn't really hold you accountable too much to this problem. If you just follow your calculator, this is the answer you get. But if you follow the actual graph, you can get a different answer. So it's like this red answer plus pi over 2 or something. But don't stress about it, because the mathematicians don't seem too angst about it. So let's just let it go. Okay? But it's not on my test anyway, right? Because I'm not using the calculator. Okay, yes, question?
Would the red portion be considered limit, or like how it shapes out at 0?
Yeah, they have different features. If you go with the red one, it's a broken graph with an asymptote in it. If you go with the blue one, it's nice and continuous. Another reason why we just need to eventually decide on this, I feel, but people haven't. So if you go online and you look up what is the arc-caught graph, you'll see different websites say different things. Yeah. Okay. So let's go to the sec(x) question. And so this one's going to have more than one answer. And here's why. Sec(x) looks like, remember what cosine looks like? This is cosine, right? This is cosine. And secant looks like this. Burp, 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 burp. Remember this guy? Kind of a weird graph, right? So this is the sec graph. And look at the question. What I'm asking you is for you to find where sec is negative 4.3. So what you could do is you go down here to negative 4.3 and draw yourself a line. See? And you can see there are many, many intersection points. There's one right there, 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 there's one right there. See what's going on? So this is the kind of problem that just has multiple answers. Okay, so first thing you're going to do is maybe write it as a cosine problem. So just first write it as cosine x equals 1 over negative 4.3. That way you can get it started. And then you do an inverse cosine. Okay, so you would do inverse cosine 1 over negative 4.3. And some of you might have a different version of this test that says 3.4. So I'm just doing the Form A of my exam. In any case, this gives you basically x is 1.806 radians. Okay, so how do you get all the others? Well, there's a couple ways to do it. One is you can think, on the unit circle, right? When I know that cosine is negative something, that gives me a point right there and right there. Right? So for example, if cosine is negative 1/2, it gives you these 2 points, one above the other, on the left side. So these would both have negative 1/2 for their cosine. Right? In the same way, for cosine to be negative 1 over 4.3, which is like negative 0.2 something, you would have 2 points here, not 1. So if the first answer is theta, the other answer is 2 pi minus theta. So it's just a complete circle minus this arc. Okay. Or you can do theta and negative theta. So you can just put plus or minus on that. That would work too. It just says keep things positive. So I want to keep it positive. So I'm going to do this and 2 pi minus that. And that's kind of what we do with inverse cosines when we have to perform them. You know, like when we square root both sides, we do plus or minus? When you inverse cosine both sides, you do answer on calculator and 2 pi minus answer on the calculator. So 2 pi minus the answer is 4.478. Okay? 4.478. So you have to kind of know when are there 2 answers, when is there 1 answer, and it's because of this graphical feature. Okay? All right. Let's go to the next one, and that's down here. Solve for all values. Yeah, it was 2 pi minus the answer. That's just kind of how you handle a cosine problem like that, or secant. Let's go to this one. So hopefully you just saw the chance to factor this thing. So I'm trying to remember how it factors. I think it goes 3 cosec minus
Plus
2, or plus 2, right. And it's 5 cosine minus 4. Does that look right?
Yeah.
Okay, it really does work. It's factored properly, which means that cosine x is negative 2/3 and cosine x is 4/5. So you really just kind of treat cos x as if it were your x. Okay, both of these can be solved in the calculator. If you do inverse cosine of negative 2/3, you get 2.300. Don't forget the 2 pi minus that. Okay, that gives you 3.983. And we also need to solve the other one. So that's this one here. Cosine x is 4/5. So you do inverse cosine of 4/5. And don't forget the second possible solution. So you get another pair of x's. X is 0.644, rounded to the nearest thousandth, and x is 5.6396. So we're just going to go 640. This again is 2 pi minus the previous answer. So what's going on in this problem is you have a very complicated graph, and it has many, many solutions, many, many roots. See how it says equals 0? It's a goofy graph with many roots, and we found 4 of them. They are the ones between 0 and 2 pi. Technically, if you want to do all possible x's, you then add 2 pi k to everything here. See? That just makes sure we get all the coterminal guys, positive and negative. Okay, let's go to next page. So this is where we kind of would, test more directly. But I remember one of these questions had a typo, so I'll try to catch it when I get there. This is just saying what angle has a cosine that's negative 1/2. And there are actually 2 angles on the unit circle where this happens. It happens at 2 pi over 3, and it also happens at 4 pi over 3. See? But when you're doing an inverse cosine problem, the range, that means the answers you're allowed to give, have to be between 0 and pi. So the range is 0 is less than or equal to y is less than or equal to pi. That means you cannot answer 4 pi over 3 because it's out of range. So you're going to have to just go with 2 pi over 3. See? And that's why we're going to go with A. You cannot answer C. It's just not in the range, even though it has the right cosine value. Okay, so it has to be an answer between 0 and pi. Okay. The next one's basically saying, what is tan inverse of tan of 5 pi over 6? So this one you can kind of work it from the inside out. First figure out what this is. Tan 5 pi over 6. So this is the point, negative rad 3 over 2 comma half. So when you perform a tan on that thing, you're going to get negative 1 over rad 3. So you're going to basically get negative 1/2 over rad 3 over 2 like that, which is going to basically all boil down to negative root 3 over 3. Okay, now what you're looking at is a brand new question. And you have to be very careful with it. Now you're going to look back at the unit circle. This time you're trying to find angles whose tangents are negative root 3 over 3. And you'll find 2 of them. This one here and this one here. Okay? But it's an arctan, which means there's a certain range that you're allowed to look in. And the range on this guy is negative pi over 2 to pi over 2. That means you have to pick a number like 60 degrees, negative 30 degrees, something between negative 90 and 90. You do not have full reign of the circle. So you have to be looking in this region only and choosing. That means we're going to have to choose this dot, and we have to be careful what we call it. We can't call it 11 pi over 6, even though that's one of its names. What do we have to call it?
Negative pi over 6.
We have to call it negative pi over 6. It's because of the rules of range. So the answer to this problem is D. That's a hard one, because just when you think you've got it, you've got multiple answers that look right. So the answer is not A, actually. Okay? You cannot just cancel out the tan and the inverse tan, because your answer comes out of range. Okay. Let's erase the ink. Sorry, I have to keep erasing here. So let's go on to the next problem. Find the exact value. Now, last time we kind of learned a lesson. We're not just going to cross these out, okay? It's better to just work it from the inside out. So if you look at 4 pi over 3 on the unit circle, maybe you did that during your corrections phase, you'll find that this is just negative 1/2. No big deal. But now it's an inverse cosine question, which means you're going to have to look at the right range. So the range is, as we said a minute ago, 0 to pi. That means you're going to have to give me a different angle from this region that has the same cosine. So that would, of course, be the point directly above it. This also has cosine -1/2. Cosine is -1/2, just like the point below it. And so we're going to answer that one instead. So the answer is 2 pi over 3. Okay? All right, next is find the value of inverse sine of tan 3 pi over 4. If you need degrees on these things, by the way, you can always change them. Just think of it as sine inverse of tan 135. If you like degrees better, be my guest. Okay? So the unit circle, we're talking about right there. But, you know, the coordinates on this point are equal and opposite. So tangent right there is actually -1. So this whole question boils down to what angle has a sine of -1? So you go back to the circle again. Only this time it's an arcsine question, which means it has a particular range. What is the range? -pi/2 to pi/2. So you have to look here for an angle whose sine is -1, which of course is this point down at the bottom. Okay, this is my answer. But we have to be careful what we call it. We can't call it 270. We can't call it 3 pi over 2. We have to answer within range. So what's the best answer for this question? -pi/2, right. So even after you get the right spot, you have to give it the right name, see? Because each point has an infinite number of names. So watch those ranges. I find this very hard to teach. Just doing the best I can. Maybe you can watch it again and follow it one more time if you're not getting it. Here's another problem where I'm just reluctant to cross these out, right? Let's just play around with it for a minute. What angle has a cosine that's -1? That is a very unique point, actually. Only pi has this feature if you're in the first revolution, okay? So cos pi is the question now, and -1 is the answer. So very reluctant to just sort of cross these out, but it turns out that actually would have worked here. Okay, the next question, it's very tempting to do this. If cosecant is 4/5, it's very tempting just to assume then that sine is 5/4. So a lot of people just wrote this as sine of 5/4. Just kind of were thinking, well, if hypotenuse over opposite is 4/5, then opposite over hypotenuse is 5/4. There's a problem with this, though. Can sine be 5/4? No. In fact, cosecant can't be 4/5. Remember, this makes no sense. How can r over y be 4/5? R is supposed to be the longest side of the triangle. How can you have a triangle whose hypotenuse is 5 and the y is hypotenuse is 4, the y is 5? It makes no sense. So it's a trick question. But it's a fair question. It's the same thing as I wrote here, answer this, square root of -2. You would write undefined, right? Or if I said, here, write the answer, 1/0. What is it? Undefined. Cosecant of, the cosecant is 4/5. Answer, undefined. See? So they are fair questions, but they're a little tricky. Okay, let's go to the next one. Okay, now you can't just use your unit circle on every problem. So sometimes you use your identity sheet instead. Okay? So let me pause my recording and pull up my identity sheet real quick. Okay? Okay, so you can use these here to help you identify what kinds of problems you're dealing with. So like on this problem we were just doing, sorry, go through my stuff here. Here it is. You can see that this looks like, see the half right there? This looks like cosine of half of something. See, just the way it looks. So that's a clue, see? So we're going to go to our cheat sheet here. Cosine of half of something, cosine of half of something. Where is that? let's see, that's actually way down here at the bottom, right there. Cosine of half alpha. Okay, so the rule is 1 plus cos alpha over 2. Okay, so let's go to, back to our test here. Let's draw a little picture of this tan inverse 3/4 thing. So what this is saying is, we're at the point 4, 3. That's why tangent's 3/4. Obviously this would be 5. It's a 3, 4, 5 triangle. And the formula for cos half something is always plus or minus the square root of 1 plus cosine of the something all over 2. So this is just a formula. And we can tell what cosine is looking at our little picture. Okay, so what's cosine? Look at the picture I drew. X over R. 4/5, right? So you would just substitute that in. So cosine of 1/2 theta would be plus or minus square root of 1 plus 4/5 all over 2, which really gives you 9/10 on the inside if you simplify it all. And there is a plus or minus issue going on here, but we're technically in quadrant 1. I know that because I drew it. And half of an angle in quadrant 1 is still an angle in quadrant 1. So I don't think I even need the minus for this problem. You kind of need to decide, do you need it or not? And I definitely don't need it here because everything seems to be quadrant 1. So I'm going to ditch the minus sign. Okay, let's get rid of that. We'll just do plus only. And we're going to go with A. It's 3 over root 10, so it's 3 root 10 over 10. Let's go to number 2. So for number 2 on this page, it's the same game, slightly different picture. Let's see here. Secant of 2 times something. Secant of 2 times something. See the 2 right there? Let's go to our cheat sheet and see what we got here. Secant of 2 times something. Do I have that? Here are some double angle formulas, but I don't see secant. That's no big deal. I'll just use the cosine ones, and I'll slap a 1 on top. Okay? So I'm going to pick one of these 3 right here, and I'll just put a 1 over that. Okay, so let's go back to our test. Here it is. Oops, this one. Okay, so here's my choices, okay? I can do 1 over cos squared minus sine squared. That's one option. Or I could do 1 over 2 cos squared minus 1. Or I could do 1 over 1 minus 2 sine squared. My choice. Now, seeing that sine is 4/7, which might be the wisest of the 3 to choose? The third one's my best choice because I don't even need cosine. So I'm just going to get rid of those, and I'm just going to go straight for the problem here. I already know that sine is 4/7. So if you work this out carefully, you get 49/17. I'll skip the work. You basically get 1 over 17/49, which is 49/17. So it's not a very hard problem at all. You have to definitely identify what style of problem it is. You have to know the formulas well enough to choose one. If you decided to choose one of these other ones, that's fine too, but you'll need to find cosine, which means you'll have to draw a little picture. And I think cosine was a little awkward. I think it was like root 33 over 7 or something weird. Okay? That's awkward. But we didn't need it technically. Let's go to the next problem. So this one says, find the exact value of blah, blah, blah. And this one looks like sine of something plus something. See? This is just the overall structure of it. It looks like that. Okay, which means we would need to know sine alpha and cos beta and cos alpha and sine beta, which is the proper expansion for a sine of 2 things added. Okay, so this is going to be kind of a difficult one. We need 2 pictures, one for each arc statement they gave us. Okay? So for the first arc statement they gave us, I could draw a picture that looks like this. I'll call this the alpha picture. And x is 3, see? And y is unknown, but r is 5. I'm pretty sure it's 3, 4, 5. See? All right. And the second picture, I'll draw that as beta. It's saying that secant is 13/12. That just means cosine is 12/13. So it's in the same quadrant. This time it's 12 comma something, and the r is 13. I think this is just a 5/12/13 pattern. You can use Pythagorean theorem if you need. 169 minus 144 is 25. Squared that. Okay, so I have my two pictures, and I'm ready to fill in my blanks. There are 4 of them. First I need sine alpha. That's from the first picture. Then I need cos beta. That's from the second picture, or from the given. Then I have cos alpha, so back to the first picture. And finally sine beta, down to the second picture. So you just basically end up with 48 plus 15 over 65, 63 over 65. And I just want to point out something funny about this problem. It couldn't possibly be answer choice C. Can someone tell me why?
It's going to be greater than 1.
Yeah, how could sine of anything be greater than 1? This is a sine question, first and foremost. It's a sine problem. So it says sine right in front. So there's no way it could have been 77 over 65. All right. Okay, let's go on to number 4, which is actually to the right and up a bit. So let me scroll over. Let's see here. Number 4. Oh, okay, so sorry, this kind of got cut off here. I don't know if yours did, but mine did. Oops, I didn't need that. Okay, so this looks to me like cosine of something plus something, see? So I'm looking first at the way it appears. So it looks like cosine of something plus something, whose expansion is cos alpha cos beta minus sine alpha sine beta. The pictures are going to be weird, okay? The first picture is that cosine is v over 1. Weird. So I'm going to draw a picture of that. I'm trying to draw a picture where cosine is v over 1. I guess x is v and r is 1. So this leaves me with the question, what is my y here? Well, it turns out that since 1 squared plus y squared is v squared, okay, I wrote that wrong. I meant to write, since v squared plus y squared is 1, I can tell that y is the square root of 1 minus v squared. So that is really awkward, but it is what it is. Okay, but there's my picture. And let's draw a picture for this second one. I guess sine is now v, so it looks like this for my beta picture. Sine is now v, so that means the opposite is v, or the y is v, and the r is 1. And writing down x squared plus v squared equals 1 tells me that this is the square root of 1 minus v squared. So these are awkward diagrams, but they are perfectly sufficient to solve the problem. So now we're ready to start. I need cos alpha cos beta minus sine alpha sine beta. And if you look at the first picture and you look at cosine, you get v. If you look at the second picture and look at cosine, you get square root of 1 minus v squared. If you look back at the first picture and look at sine, you get square root of 1 minus v squared. And if you look at the second picture and look at sine, you get v. Wait a minute, this is just all 0. It's v root 1 minus v squared minus v root 1 minus v squared. The answer is 0. Okay, now I'm going to show you how to do this problem in 2 seconds. Okay? I'm thinking of an angle whose cosine is a number and whose sine is the same number. Look, they both say v. I'm thinking of an angle, cosine is v and sine is v. That's 45 degrees. Think about the unit circle. Where else would there be equal sine and cosine? What's this? This is 45 degrees. And so is that. Because cosine and sine are the same. So what's 45 plus 45? 90. And what's cosine of 90? Okay, but see, that takes a little bit more training. You just didn't know that, but you could look back at the other problems and still follow the patterns. And I guess you could say in a weird sort of way, this kind of proves that cosine of 45 and sine of 45 are the same, in a weird way. Our work, you know, if you start with different premises. Okay, this problem could be really hard, but you'll notice there's a sign in both terms. So why don't we pop the sign out, and we have 1 minus sec, 1 over sec squared, I'm sorry, 1 over sec squared minus 1 over cosec squared. Okay. Now you can see that the answer is sine times something. See? So I'm really looking at answer choice B here. Or maybe it's none of the above. But it's got that extra sign out front, see it? I'm not sure I'm done yet, but I want to pursue it a little bit. I think I have a clue that it might be B or F for this. Anyway, what's 1 over sec? 1 over sec. Isn't that just cosine? So what's 1 over sec squared? Cosine squared. Okay. So this is just basically cosine squared. And 1 over cosecant is the same thing as sine. So this is just sine squared. Cosine squared minus sine squared. Boy, that sounds so familiar. Going back to our cheat sheet, cosine squared minus sine squared. There it is. Cos 2 theta. Okay, let's go back and replace that with a cos 2 theta. Answer B. So what I did first on that problem was a little algebra. I pulled out the sign. Then I looked at the identities that were existing. Some of you waited and you tried to deal with the sign, and you got it right too. You pulled it out later, which is fine. Okay, let's go to our next problem. Number 6, which is down at the bottom. To the left a bit. There it is. Okay, so this is actually a little bit easier. This is telling you exactly what you're looking for. So you can choose 2 cosine squared minus 1. That's a really good choice for this formula because they gave you cosine. So why not just plug in negative 1/4? So you get 2/16 minus 1, which is like 2/16 minus 16/16, which is negative 4/16. In other words, negative 7/8. So this one's a really straightforward problem if you know your formulas. Same thing with the next one. Sine is 1/3, so I'm going to draw a picture of that. Oh, and it says that I have to stick to quadrant 2. Okay, so this is a bad drawing. Mr. Shore, you need to be in quadrant 2. Okay, I'm sorry. So it turns out that this is my drawing, quadrant 2 version, and that means that this is going to be the square root of what's 9 minus 1?
2.
Okay, 8, right? So this is square root of 8. So I'm going to write 2 root 2, and it's negative because it's on the left. Okay, now I'm ready to answer the question. Tan half angle, that's one of our ugliest formulas. Or one of our simplest formulas, depending on which one you look at. So many of you tried to use this gnarliness to solve the problem. That thing is awful. Look at the other alternatives I gave you. So much better. No square root, no complex fraction, no plus or minus. So I suggest we choose one of these. Let's go back to our picture real quick so we can decide which one we want to use. It looks to me like cosine is going to be a little ugly because it's got this 2 root 2. So if you look at your identities, I would really like ugly on top, not ugly on bottom, if you know what I mean. So I'd rather have the cosine upstairs. So I'm going to vote on this one because sine is a nice clean number with no radicals, and it's going to end up on the denominator. So I'm going to do cosine over 1 minus sine. That's my final decision. I'm going to do cosine over 1 minus sine, which is negative 2 root 2 over 3 over 1 minus 1/3, which is negative 2 root 2 over 3 over 2/3. And so I got a little sloppy there. The 2's and 3's cancel out, and the answer is just simply negative root 2. Is that true? Seems a little simplistic here. Negative root 2. Is that what you guys got? Did anyone get that one right? It just seems awfully simplistic to me. Doesn't seem quite right. Does anyone see my error? 9 minus 1 is 8, right? So it's root 8. It's negative. Cosine over 1 minus sine. 2/3 cancels out. Don't see any errors there. Does anyone see my mistake? Did anyone get this problem right?
I think it was 3 plus 2 radical 2.
That sounds right to me. Is my formula wrong on my identity sheet?
I have 1 minus cosine alpha over sine alpha.
1 minus cosine over sine. Okay, my identity sheet was wrong there. So I had the wrong formula. 1 minus cosine over sine. Yeah, I think I just now did a search on my hard drive for identity sheets, and I found one that had a flaw in it. I think the one I gave you was fine, but let's go ahead and fix this. So it's 1 minus negative 2 root 2 over 3 over 1/3. Okay, so this gives me 3 plus 2 root 2 when it's all cleaned up. Okay, I'll skip the steps because I wasted a little time there, sorry. Okay, so moral of the story is make sure your identity sheet has the right formulas on it. Okay, and the one I gave you did. I still like that one though because it had the sign on the bottom. Okay, thank you, Yasira. Okay, now here's a problem that says find the cosine of 7 pi over 8. The problem with that is that's not on the unit circle. Okay, so if you think of it, 7 pi over 8, if you convert this to degrees real quick, you get 167.5. 7/8 of 180. 157.5. So you don't have to do that. I'm just trying to show you that there is no way you could do this just by looking at the unit circle. This is not one of our angles, right? But it is half of one of our angles, technically. It is exactly half of 315. Okay? So you can think of this as 315 over 2. So why is that helpful? Because we are trying to find cosine of 315 over 2. And yeah, that's not a special angle, but you can use a half angle identity. So you would just go like this, plus or minus square root of 1 plus cos 315 all over 2, which is 1 plus root 2 over 2 over 2, which gives you 2 plus root 2 over 4 square rooted, and you can even square root that 4 on the bottom. So you get plus or minus square root of 2 plus root 2, and this is all over 2, or you can put a half in front. Okay, now which is it? Cosine of 157.5 is what it means. I'm in quadrant 2, where cosines really should be negative. So I'm going to decide on my sign now. I'm going to go with a minus for this problem. The answer is minus 1/2 square root 2 plus rad 2. I'll rewrite the answer. Negative 1/2 square root of 2 plus root 2. And even if you couldn't simplify it perfectly, I think I still gave you credit. So hopefully that one's no mistakes there. Okay, let's go to this one. This is basically saying that we have an alpha drawing, and this is 2 and 3, which naturally makes this root 5. Oh, but I was supposed to draw it down here, so it's going to look like this. Oops, I put my r in the wrong spot. The r is longer than the x. So this is the 3, this is the 2. I'm in quadrant 4, my bad. Start over. Quadrant 4, it says, drawing looks like this. R is 3, x is 2, this is negative root 5. There we go. That's my alpha picture. Then I need a beta picture. For beta, let's see, it's supposed to have a positive sine of 1/4, but it looks like they're saying cosine's negative. Cosine's negative. So sine is positive, but cosine's negative. That would be quadrant 2. So that's sort of cryptic, but we're definitely in quadrant 2 there, where the picture looks like this. This is 1 and this is 4. So this would have to be negative root 15. 16 minus 1. Okay? Square root. Okay, now I got my two pictures, and then this just becomes a cos alpha plus beta problem. So you're going to need cos, cos, minus sine, sine, like that, and 4 fractions. So cosine, 2/3, cosine, negative root 15 over 4, sine, negative root 5 over 3, sine, 1/4. So the answer is negative 2 root 15 plus root 5 all over 12. There's no root 15. It's a root 5. Yeah, there's a root 15. Never mind. Okay. Let's go to the next one. Look, sec squared minus tan squared should look familiar to you. It's just 1. It's straight off your identity sheet. So you can start with that. And 1 minus cos squared is sine squared. Mr. Lynch calls 1 minus cos squared equals sine squared. He calls that Mama's theorem. I have no idea why. Maybe because it's used so much and it's like so important, like it's fundamentally important. So he calls it Mama's theorem. He's a funny guy. Okay. He really is. All right, let's go to this problem. So for this one, I would just multiply this up to here and this up to here and these together. So it would look like this. Cosine minus cosine squared plus cosine plus cosine squared all over 1 minus cos squared. So I just followed the arrows and I multiplied. In order, it's 1, 2, 3. This is 1, 2, 3. Okay? All right. In any case, the top basically collapses into 2 cosine thetas, and the bottom is clearly a sine squared because of Mama's theorem. And now the question is, why is this 2 cot cosecant? So you can just see the 2 there, obviously. And then you could think of this as a cosine over a sine sine. Or even a cosine times 1 over a 1 over sine. I'm sorry, a cosine times 1 over a sine times sine. And you can kind of just group it into 2 cot cosecant. There's your cot. There's your cosecant. So that one's proven. QED, right. This next one, you might want to write this as sine over cosine. Like this. Don't even touch the right side. And then we'll follow the arrows again. We'll multiply this up to here, that's step 1. Multiply this up to here, that's step 2. And then we'll multiply the denominators together. Okay, so this is going to look like cos squared plus sine squared all over cosine. And I don't really want to distribute that denominator yet. This should say, cosine squared. Sorry about that. So it's cosine squared plus sine squared. And look, you can see there's a 1 here. See the cos squared plus sine squared? So we have basically 1 plus sine over cosine times 1 plus sine. So this part is 1. These two guys. So we have 1 plus sine over cosine times 1 plus sine. And then this cancels out. So you get 1 over cos, which is by definition secant. And it's supposed to be working side by side and going down the page, but I knew I would run out of room, so I went sideways on that. Next is this one. This is a really easy one, actually. Just expand the top into sine, cos, plus cos sine. And since this is over cos alpha sine beta, you can just kind of circle this part and this part separately. And you get sine alpha cos beta over cos alpha sine beta plus cos alpha cos sine beta, over cos alpha sine beta. And if you look closely at this, you can see the tan alpha right there. There's a cot beta right there, and this whole nonsense is 1. So it's just basically tan alpha cot beta plus 1. I think that one was straight out of the homework. Okay, that leads us to our last question. And that's solving here. So you can't have a 2x and an x as two different angles. So you're going to have to work on this and get it cleaned up. So my suggestion is you look on the identity sheet for something for sine 2x, and the only option is 2 sine x cos x. And now you realize everything's in angle x now. There's no 2x anymore. So you can just pop a sine out. And this means that sine x is 0, right? Or, if you look at this part, right here, 2 cosine x minus 1 equals 0. This gives you x equals 0, pi, 2 pi. In fact, x can be any multiple of pi. We're just solving between 0 and 2 pi, so we'll just keep just 0 and pi. And then the other one is saying that cosine is a half, basically. So cosine of x is a half, which conjures up angles like, pi over 3 has that feature. 5 pi over 3 has that feature. See? And others too, but we're just doing the ones between 0 and 2 pi. And then the last problem, you could just subtract 3 over. Just think of this right here as theta, okay? Theta. Just think of it as theta. Imagine if you were dealing with this problem. That's not a hard problem. You would divide by root 3, which would ultimately give you something like this. If you do, I'm sorry, it's negative root 3. So you divide negative 3 by root 3, and you get negative root 3. If I give you this problem, you wouldn't have any trouble with it. So just think of it this way. We'll put the theta back in later. So this gives you theta is equal to, and I believe the angle is 11 pi over 12, or you could just put negative pi over 6, negative pi over 6, plus k pi, because it's a cot. And then since this is 2x minus pi, you can just put that right back in. You're going to be adding pi over, which makes this a 5 pi over 6, and dividing by 2, which gives you 5 pi over 12 plus pi over 2k. And then you can plug in values of k, like you can plug in 0 and 1 to get a couple answers that are between 0 and 2 pi. Okay, so that's chapter 6. And I'll record the others too. Okay, have a great day.